For this first set of equations, we are to find the slope from a graph. Now our slope, we are going to use rise over run to organize that. So we need to find out how far things go up and down and how far things go side to side from any 2 points on the graph. Now we're given a picture of 2 points right here, but really we could use any spot along the line. I'm going to use the 2 that are given on each of these pictures just because that will make my life a little easier. Now we can see that we go up 1, 2, 3, 4, 5 on this one. So our rise is 5. For the run, we do not go side to side. That means that it is 0. And when we divide by 0, we call that undefined. So the slope on this one is undefined. That is the case for every single vertical line because the run will always be 0 if we go straight up and down. On the next one, we're going down and to the right. We go down 2, it's going to be negative because we're going down, and we go to the right 3. So when we do our rise over run, then we end up with negative 2 over 3. So that would be our slope for this one. On the next task, we're going straight horizontally, side to side. We go 1, 2, 3, 4, 5 to the side. That would be our run. And our rise in this case is going to end up being 0 because we do not go up, we do not go down. So we end up with 0 over 5. Now any number divided by 5 is 0, so our slope ends up being 0. With horizontal lines, that will always be the case because when we don't go up or down, then our rise will always be 0. So we'll see that with every horizontal line. On question number 4, we go up and to the right. So we go up 1, 2, 3, 4, 5, 6 spaces, and we go to the right 1. So for our rise and our run, we go up 6 and to the right 1, and that is our slope. On this next set of questions, we have a table of values, and we've got a couple of choices. You could graph these if you wish, or we could just take a look and see how they change from one step to the next. Our rise will end up being our change in our y values because that's going up and down. The y value is what goes up and down. Our run will end up being our change in x values because run goes side to side, and that is an x value that goes side to side. So if we look at the pattern here, we can see that we're going down by 4, down by 4, down by 4, and then on the x values we're going up by 2, up by 2, up by 2. So every time we go down 4, we go to the right 2. So our rise and our run will be down 4 and right 2, and organizing that as rise over run, we'd have negative 4 over 2. Now we can simplify that. Negative 4 divided by 2 is the same as negative 2 divided by 1. So you could write it this way, negative 2 divided by 1, or just as negative 2. Either one of those would be acceptable. This is also acceptable, but I would encourage you to reduce your fractions when possible. On the next one, our y values are going up by 12 in each of these cases, up by 12, and each of these goes up by 3, up by 3, up by 3, and we end up with our rise of 12 and our run of 3. That simplifies to 4 over 1, or you could write that as 4. Any one of these would be acceptable, but again, I would encourage you to reduce your fractions. On this next one, we have pattern of negative 4. We're going down by 4 for each of these, and our x values go down by 6, down by 6, down by 6. So our rise and our run will be negative 4 for our rise, negative 6 for our run. This simplifies. 2 goes into both 4 and 6. That will go into 4 2 times and 6 3 times. And a negative divided by negative ends up being positive. So I'm going to write it this way as positive 2/3. And our last one with the grid, we can see that our y values go nowhere. Plus 0, plus 0, plus 0. And our x values are going up by 5 for each of these. And that gives us a rise of 0 and a run of 5. 0 divided by 5 is 0. So this is a horizontal line as we talked about earlier. And we could see that just by visualizing these y values. If they stay at negative 15, it's going to be horizontal. Now I did want to mention one more thing on this. Sometimes our pattern skips around a little bit, and so we might see a situation like this where our x value goes 1, 3, and then maybe it'll skip and go to 7. So we're going up by 2, and then we go up by 4, and we have to check the y values that go along with this. And so if we have something like 0 and 5 and then 15 right here, we can see that we go up by 5 and then up by 10. Now, this might look like it's not linear, but if we take our rise and our run, we end up with 5 over 2 from these two, and we end up with 10 over 4 for those two. If we reduce that fraction right there, 2 goes into 10 5 times, and 2 goes into 4 2 times, and we end up with the same fraction in either place. So even though these don't look like they have a consistent pattern, when we reduce the fractions, we can see that the slope for both of those is the same. It ends up being 5 over 2, which is the reason why I encourage you to simplify your slopes where possible. For our next set of questions, we're going to be graphing this from slope-intercept form. Slope-intercept form is y equals mx plus b, where m is our slope and b is our y-intercept. So if we know those two things, we can use them to put points on the graph. This one matches up nicely, where -2 is our m value, that's our slope, and -1 is our y-intercept. So we're going to write that down here, -2 and -1. For the slope, I like it to be fraction form for rise over run, so I'm going to make that -2 over 1. All right, we're going to graph this by starting with our y-intercept. It's at -1, so I'm going to put that on the grid. Then our slope tells us to go down 2 and to the right 1. We're going to get a few points that direction. I like to have some points both directions, so I'm going to reverse that by going up 2 and left 1 as well. Get a few points the other direction, and that gives us a nice set of points to be able to connect and create our line. For the next one, we can see our slope is -3/2, and our y-intercept is 1. So we're going to start at our y-intercept again, and then our slope of -3/2 tells us we're going to go down 3 and to the right 2. If I do that, down 3 and to the right 2, down 3 and to the right 2, and then we reverse that by going up 3 and to the left 2. That gives us a nice set of points again that we can connect to draw our line. For this one, it looks a little bit different. Our y value is 3. We can see our y value is 3 right there. And we want our y value to stay at 3, so we can't go up, can't go down. The only direction we can go on this one is horizontal if we want our y values to stay 3. So this ends up being a horizontal line here at y equals 3. As we saw before, our slope for horizontal lines is going to be 0, and our y-intercept is 3, and that finishes up this question. For this one, our x value needs to stay at -4. X value is -4 right there, and if we want to stay at -4, we are not allowed to go to the left or the right. That leaves us with a line that goes up or down, like so. So we have a vertical line, and as discussed earlier, slope of a vertical line is undefined. Now if I think for a second about this, the fact that this goes straight up and down, we realize that we are never going to cross the y-intercept. It's going to stay away from it, and so there is no y-intercept, so I'm going to just write none there. On the next two questions, we want to get slope-intercept form, y equals mx plus b, but it doesn't start off that way. So we need to rearrange this to solve for the y value. If we do that, then we will have it in slope-intercept form. So we're going to do that by adding the x to both sides. That will give us 2y on the left. And over here I'm going to write this with the x first, so positive x plus 10. And then we're going to finish this out by dividing by 2. I need to make sure I divide both of these by 2. So that gives me y. The 10 divides nicely by 2, it's 5. And normally I don't write the 1 in front of the x, but I like it here in this case because that shows me my slope is 1/2. And a plus there because it's positive, so now I can see my slope is 1/2. My y-intercept is 5, so I'm going to start here at 5 for my y-intercept, go up 1 and to the right 2 to go that direction, down 1 and to the left 2 to go this direction, and we've got our line. And our last question right here, we're going to do the same thing, solve for our y value. So we're going to subtract 4x on this side, we end up with negative y. Make sure to keep that track of that negative right there. And on this other side, both of these are negative as well. So I'm going to write negative 4x and minus 8. To get rid of this negative, we're going to divide by negative 1. Divide both of these by negative 1. So a negative divided by negative ends up being positive. We're left with positive y. Over here, negative 4 divided by negative 1 is positive 4x. And negative 8 divided by negative 1 is positive 8. So let's put this in fraction form. 8 is not on our grid, so we're going to go up a couple more here to get that y-intercept of 8. And this slope tells us to go up 4 and to the right 1. Now that's going to take me even farther off my grid. So I'm going to reverse that by going down 4 and to the left 1, down 4 and to the left 1. Get a few points here, and that will give us a nice straight line again. Thank you very much, and good luck.